All right, algebra, lesson 2.3, point slope form of a linear equation. Our objective, you guys should be able to identify the point slope form of a line and convert it into slope intercept form. All right, let's go. Must be asking yourself, what is point slope form? Well, it's a form of a line equation that looks like this. Y minus y1 equals m times x minus x1. And x1 is the x-coordinate of a point. I am in my cardigan. And y1 is the y-coordinate of a point. And m, and you should know this by now, is the slope. So I have some slope m, some point x1, y1, and I put it into this equation, and that gives me the equation of a line. This is particularly useful if we don't have a y-intercept. Not useful. Or if we have 2 points and neither are the y-intercept. And we'll do a couple sample problems and you'll see what I mean. So this should sound redundant. We use the point slope form when we have slope and a point that is not the y-intercept. So here's our slope. I'm going to write that equals m. And this is our point. And what I like to do is I label the points x1, y1. So before I try to plug it in the formula, I don't get confused. So our formula is y minus y1 equals the slope times x minus x1. And now you see why we did all that distribution practice earlier. So now I'm going to substitute in the things that I know. I'm going to change colors. We'll go to blue. I have y minus y1 is 5. Slope is 2 times x minus x1 is 2. Okay, that's the point slope formula. We can simplify a little bit if we wanted to, but we're going to stop right there, okay? From here, you should understand how to do just about anything to that equation. But let's move on to the next example. How is it helpful? What if we don't know the slope? We don't know the slope. What do we do? Oh no. Well, I have 2 points. So remember our slope formula, y1 minus y2 over x1 minus x2. So let's label these. I don't know if you can hear the cars driving by. So let's solve our slope. So I'm going to plug in what I know. I have 5 minus negative 3 over 3 minus negative 2. It's going to give me 8 on the top. That's 5 minus a minus turns into plus. 5 plus 3. 3 minus a minus 2. That turns into 3 plus 2. 8 over 5. Slope. So let's do it. Remember our formula here. Y minus y1 equals m slope times x minus x1. So y minus, let's use this point here. I put it in parentheses so I don't confuse and mistakenly just use that negative symbol. You'll see what I mean. I'll show you what not to do in the future. And then, sorry, m is 8 over 5 times x minus 2. Uh-oh, see the mistake? The formula is x minus x1, but x1 is negative 2. So that's no good, okay? And erase that. X minus x1. There's too many negatives in parentheses, so let's fix it. Y plus 3 equals 8 over 5 times x plus 2. All right, let's see the next example. 2 points again. Well, first, let's write down what the formula looks like. Y minus y1 times the slope times x minus x1. We don't know what the slope is, so let's find it. I label my points, x-coordinate, y-coordinate, x-coordinate, y-coordinate. And then I plug it into my slope formula. Okay, I should be sick of slope formula by now. 11 minus 6 over 5 minus negative 4. That's 5 over 9. Okay, that's my slope. So let's plug in what I know. I have slope. I have 2 points here. Okay, let's do y minus 11. Let's use y2 over 9 times x minus 5. And we're good. Okay, so now I have 2 points again. We're going to write an equation in point-slope form, right, which is point-slope form, y minus y1 times slope times x minus x1. And then we're going to convert it into slope-intercept, okay? So first we need our slope, and I'm not going to write the formula. You should know it by now. 4 minus negative 1 over 5 minus negative 4. That equals 5 over 9 again. How lovely. And so let's do y minus 4 equals 5 over 9 times x minus 5. Well, this is our point slope form. I need to get it into slope intercept, which is y equals slope times x, and then plus b, which is the y-intercept. How do I do that? It looks like we just have to solve for y. So remember literal equations when we had more than one variable? That's what we're doing now. So first, let's simplify the right-hand side. So I'm going to rewrite the equation, y minus 4 equals 5 ninths x minus 25 over 9. 5 ninths times negative 5 is negative 25 over 9. Then I'm going to add 4 to both sides to get rid of that 4. Negative 4 plus 4 is 0. So I get y equals 5 over 9x. That stays the same because it's a variable term. I cannot add a constant to it. But let's move this over here. I get 25 over 9 negative plus 4 over 1. We need common denominators, so now I have 25 over 9 plus I multiply the top and the bottom by 9, and I get 36 over 9. 25 plus 36, that equals 11 over 9. Final answer. Now, I have a question. What would happen if we used the other point? So if we use this instead of this one like we just did, what would happen? Pause the video, solve it, put it in the point slope form, then convert it in slope intercept form, and come and tell me what you find. Recap. Point slope form of the equation of a line is when you have point and slope and your point is not the y-intercept. Okay? It's y minus y1, and that equals the slope times the quantity, or parentheses, x minus x1. x1 is the x-coordinate of my point, y1 is the y-coordinate of my point, and m is the slope of that line. All right. Then, if you wanted to solve to get in point-intercept form, doing this with just variables, people. Looks like this. Okay, this is what the final solution would be in going from point slope to slope intercept form. Don't worry about this so much, but just understand you can go from point slope intercept to slope intercept form very easily. So your practice for this is going to be in the book, page 67 is where it starts. You're going to do number 11, you're going to do numbers 14 through 27, and then you're going to do number 34 through 36. Don't ask me what the assignment is. That just tells me you didn't watch the video. If you have any questions, you know how to find me. Good luck.